Alright, so in this lesson we are going to further explore quadratic functions, and we're specifically going to look at a variety of tables, graphs, and equations to see if they are quadratic or not. So this is the different groups of representations that we're going to look at. If you focus on the graphs right now, you're going to notice, hopefully, that only one of the four is a true quadratic. If you did the previous lesson, you probably learned about the fact that a quadratic is a parabola and is a U-shaped graph. So hopefully you have selected that this graph down here is the only quadratic. This one up here, if you notice, it has a curved shape. This one would be the exponential graph, and so this is not quadratic. This shape here, of course, is probably one of the easier ones to identify. This is a straight line, and so is therefore linear and not quadratic. And lastly, this shape kind of appears similar to the quadratic, but it's a nice V shape instead of a U shape. This is an absolute value graph. It is not quadratic. So the only graph on here that is quadratic is this one here. So we're going to switch back over to here, and we're going to look more closely at the equations. So there are these three equations here. The quadratic equation has a special characteristic that the other ones do not, and that is the x squared term. Okay? The only of the three equations that have an x squared term is this one here. So because of this term, this one is our quadratic equation or quadratic function. This, as you notice, does not have an x squared term, so it's not quadratic. It does have x in the exponent. So if you recall, this is an exponential graph. This one down here does not have an x squared term. It just has x. And so again, this one is not quadratic. You may recognize this one as being a linear function. It may be easier to see that this is linear by noting that this can be rewritten as 1/2 x plus 0. So that has that linear format. But it's important to know that of the three, this one is quadratic because it has the x squared term. Next, we're going to look at the three tables. We're going to start with this one at the top. In this table here, one thing that I notice is that my y values start out low at -4 and then they are increasing. So this could potentially be a quadratic. However, if I look carefully here, and especially right here, like right here, it's very easy to see that the space between the 1 and the 3.5 is 2.5. Okay? And if we notice here, if we take 3.5 and add 2.5 again, we get 6. Okay, so if we go backwards, -4 plus 2.5 is also going to be -1.5. And you can always check with a calculator. Again, I'm doing -4, my previous y term, plus 2.5, which is my rate, and that's giving me -1.5. And if I take -1.5 and add 2.5, that's giving me 1, and then so on and so forth. So we can see here that we have a constant rate of change. Constant rate of change is not something a quadratic has. It has a curved graph. So this one is not quadratic. Instead, this is linear. Okay? But we'll just stick with not quadratic. Okay, if we go to the second table here, on this one, if we notice just the direction that we're going, we start at +1, then we're going down to -2 and -3, but then we turn back up, or turn around and go back up. So here we're decreasing, we hit a minimum point, and then we're increasing. This is a huge indicator that this is quadratic. Okay, so because we went down and then hit what we call the vertex or minimum, and then went back up, this is going to give us that curved graph, and so this table would be a quadratic relationship. All right, finally we have our last table. And this one also, I notice just the direction, it seems to be going up, okay? So again, it could potentially be quadratic because we don't necessarily know what's going down or what's happening prior to this, but if we look carefully, we can see another pattern. And that pattern is that we are doubling. Again, you can usually see that pattern here from 3 to 6. It's usually pretty quick and easy to tell that, oh yeah, 3 times 2 is 6. And then 6 times 2 is 12, okay? If we go backwards, we can also see that 1.5 times 2 is 3, and 75 or 75 cents times 2 is $1.50 or 1.5. So we can see this very special pattern of multiplying repeatedly by 2. Okay, whenever we have this sort of pattern, this is exponential. And so this one is not quadratic because it is instead an exponential growth or exponential curve. So overall, you can see we have a variety of tables and graphs that we have looked at today, and now you hopefully have a better idea about what characteristics determine if it's quadratic and determine when it's not quadratic.